Ferrari has made some small progress in the last two races of the 2025 Formula One season. The updates to the floor, although still insufficient, have allowed Charles Leclerc to improve his race performance, thanks to a less unstable rear end, while his Ferrari teammate Lewis Hamilton is unfortunately still struggling to capitalize on the potential, however limited, of the SF25. We have discussed the various reasons for the difficulties encountered by the British driver in one of yesterday's videos. Looking back on the performance of the SF25 car in this start of the 2025 Formula One Championship, the narrow setup window forces the Maranello team to make compromises, as seen at the 6.174-kilometer Jeddah Corniche Circuit in Saudi Arabia, where the setup was partially decided to suit the Saudi layout. Additionally, the dynamic performance of the SF25 single-seater significantly depends on aerodynamic choices, which vary depending on the track. Specifically, with less downforce settings, the combined grip of the tires is sharply reduced, both longitudinally and laterally. In simple terms, this refers to a potential lack of aero-mechanical interaction, which can only be addressed with the aerodynamic updates that should be introduced by the Maranello engineers and technicians in the Emilia Romagna Grand Prix weekend at the Imola circuit. Going into more detail, it is known that vertical downforce helps generate grip on the ground through the suspension's work. Depending on the chosen static angles for the tires, dynamic behaviors are primarily governed by camber recovery, aimed at stabilizing the car with respect to load shifts and lateral acceleration. Looking at what happened between the Bahrain Grand Prix and the Saudi Arabian Grand Prix, it is evident that the Italian car showed different behavior in medium-speed corners. Aside from the endemic understeering issue on entry, telemetry shows Charles Leclerc's struggles on corner exit. As often happens, the Monegasque driver is aggressive on entry, gaining on his competitors. However, he suffers particularly when the Ferrari accelerates with steering angle. This, despite the fact that Charles Leclerc's driving style suffers more compared to Lewis Hamilton's. At the Bahrain International Circuit, the higher load helped manage the combined traction, while in Jeddah, this was lacking, and the right mass setup was not found to optimize the tire contact patch. In medium-speed corners, where vertical downforce is not high, the tires are stressed both laterally and longitudinally due to traction. The result of these forces must equal the vertical force provided by downforce, load transfer, and the vehicle's mass on each tire, multiplied by the grip coefficient between rubber and track surface. From this analysis, it can be concluded that McLaren and especially Red Bull, despite suffering other types of problems that they will try to address with the upcoming aerodynamic update package for Imola, are more efficient at generating downforce in these track sections. This allows them to have a greater amount of combined grip and optimal traction phase. Moreover, we know that grip generation by the tires is proportional to the slip angle. In other words, this is the angle between the tire's direction and the car's actual racing line. Ferrari struggles more with managing this, as it does not have the same baseline vertical downforce as the other top teams, as confirmed by Charles Leclerc last weekend in Saudi Arabia. An additional clarification must be made regarding the grip provided by the tires in slow corners, where longitudinal traction is key. In Saudi Arabia, this aspect was pointed out, but it does not actually represent a real performance deficit for the Ferrari. The SF25 car does not have problems when it comes to providing non-combined grip, such as in corner 1 exits. On the contrary, the Ferrari single-seater has plenty of longitudinal grip, but less lateral grip. To resolve these issues on medium to low aerodynamic load circuits, the Maranello team will need to efficiently extract downforce from the floor. This way, the setup operating window can be widened, allowing for improved combined grip and, consequently, performance in medium-speed corners. At this stage, it is also worth taking a look at a detailed analysis of the McLaren MCL39 floor, which reveals why it generates superior downforce compared to Ferrari, highlighting some key aerodynamic elements like the Venturi channels, edge vortex, and diffuser design. With Lando Norris's crash in his McLaren during the first Q3 attempt at the Jeddah circuit in Saudi Arabia, a fairly clear photo of the floor was captured by the reports which were trackside. Currently, the MCL39's platform ranks second in terms of downforce, behind Red Bull, which still has a slightly higher maximum load, although it cannot always deliver it easily. In contrast, the car from Woking is easier to get into the correct operating window. This allows it to generate the right vertical load in various situations. In technical terms, This means the key component has a wider aerodynamic map, precisely the goal Ferrari is chasing in recent months, generating stable load across a wider range of ride heights. This applies whether the car is rolling, pitching, or yawing. The design philosophy adopted by the historic British team focuses exactly on this, which is why they use a suspension system that aims for more rigidity. A significant advantage that the papaya-colored cars can exploit throughout the race weekend, showing impressive setup flexibility. That is why any type of layout poses no issue. Meanwhile, the Ferrari suffers significantly under these conditions. We have discussed this a few days ago in a previous video, referring to the supposed issue of generating grip in the SF25's slow corners. The Italian car can do this and quite well. Unfortunately, having to chase more compromises, the Maranello team in Jeddah had no choice but to sacrifice the only technical section in favor of the more numerous fast ones. Focusing specifically on McLaren's floor structure, the green highlights mark the elements that make up the initial area. Specifically, we note the two most important appendages among the four at the mouth of the Venturi channels. These are key to generating outwash, significantly increasing downforce. Their shape is therefore crucial and subject to multiple developments throughout the year. The floor produces the highest percentage of downforce in a ground effect car, and its performance must be protected as much as possible. The so-called inwash effect, where dirty air flows laterally into the floor volume, must be minimized. The better this is managed, the more effective the floor becomes. On the other hand, the fences in question direct the airflow outward. This achieves two outcomes: a forward shift in downforce generation via the so-called edge wing, which also works to divert turbulence from the front wheels. It does this by creating multiple vortices that combine into the so-called edge vortex, which seals the floor and prevents the aforementioned dirty airflow infiltration. About halfway along the appendages, a vortex detaches. The appendage design is intended to control its position. Since this vortex is strong and energized by others, it helps lower pressure further due to its high rotational speed. The Venturi channel roof is specifically designed to house large vortices with a particular structure. This is why the channel walls must be shaped to avoid disrupting their rotation, ensuring they do not break under certain driving conditions. Their trajectory changes over time depending on the floor's movement. Once again, the more stable the floor configuration, the fewer risky variations the airflow mass will experience along its path. Also important is the distinctive keel shape, with a kick at the leading edge. This geometry should increase local low pressure. Finally, we reach the diffuser, the most delicate part of the floor where airflow expands. The goal is to maximize extraction volume, where every single cubic centimeter matters. Two indentations are visible in red, designed to increase this expansion. A solution already seen on the Red Bull RB20 single-seater and partially adopted by McLaren last season.